Okay, very welcome to the session 2 of our series of in structure of atom. The basic summary of session 1, the basic summary of session 1 was atom is a very small particle and atom can be divisible, and we also know that atom cannot be seen by even by the most powerful of the powerful microscopes. So everything of or understanding of atom is generated by some experiments and the results of those experiments. So we have seen J.J. Thomson's experiment, then we have seen Goldstein's experiment, and then more importantly we have seen Rutherford's experiment. All these experiments proved that at that point of time atoms could have been in this way. Okay, so that's now going forward, let us summarize. So the three models, okay, J.J. Thomson's model, okay, J.J. Thomson model, what it discussed was an atom is similar to a pudding, okay. So and in that pudding, fruits are in the form of, dry fruits will be in the form of positive charge, okay, and negative charge. These are negative charges, and you have the rest happens to be a positive charge, the rest, like, okay. Then the electrons, this is the electrons, these negative charges are called electrons, and these electrons are in the sphere of a negative charge, okay, positive charge. This sphere is, these electrons are negative charged and they are in the sphere of a positive charge, okay. So atom is neutral, okay, as the number of positively charged particles is equal to number of negatively charged particles. Like, so whatever charge these negatively charged particles have, that will be similar to the charge contained in the positively charged sphere, okay. That's why atom is neutral. You don't, otherwise if this was not true, if you touch an atom, probably you should get a shock, but you don't do that. That means you don't get that means atom is probably electrically neutral. And why is electrically neutral, why it is electrically neutral, that is that can be told by this point, that the charge contained by this negative particles and the positive particles both are same. So that's why you are not facing any shock or something while touching an atom, okay. Then came the most important thing, that is the Rutherford. It changed the entire perception of how atom is perceived, okay. The first and the foremost thing is, atom is not a solid sphere. Most part of an atom is empty, okay, most part of an atom is empty. That was the result of the gold foil experiment. Now, center of an atom is positively charged, okay, and it is called the nucleus, okay. Center of an atom is positively charged and it is called the nucleus. It also concluded that the center of an atom is heavy, where the whole mass is concentrated, okay, and the size of the nucleus is 1/10 the size of an atom, 1/100,000, 1/100,000 the size of an atom, and the density of nucleus is very high, okay. Then a further improvement on this was the suggestions given by Niels Bohr. In his model, he said that electrons revolve around certain permitted orbits, just like this. These electrons, these orbits are like the tracks, okay. These orbits are like tracks, and the electrons are permitted to revolve around these orbits. It's what Rutherford essentially said was, electrons are Rutherford essentially said that electrons are revolving around a single particular circle, shell around the circle or shell around the nucleus, but that is not the case. As suggested by Bohr. Bohr suggested the electrons are rotating in multiple shells, and these are certain permitted orbits. He devised some calculation and then came up to it. Okay. Then electrons do not radiate energy. This is the reason why this model failed. Okay. By this model, electrons should radiate energy while revolving in orbit, but they don't. Okay. Since they are revolving in certain permitted orbits, and in those permitted orbits, it's not necessary that they radiate energy. Okay. And these orbits are called energy levels. Okay. That is what Bohr's model talks about. Then we'll now we have going by this. Okay. Whatever the structure of atom we have is electrons are, it contains of three particles. Okay. One is the electrons, the second one is the protons, the third one is the neutrons. Okay. Electrons are outside the nucleus, rotating around the nucleus. They are negatively charged. Their charge can be taken as -1. Mass is very negligible. Look, it's like 1 over 2000. I mean, the size of 1 over 2000 the mass of proton. Like if you take one proton to be as heavy as a 2 kg block, the electron will be 1 gram itself. Okay, 1 gram. So that's so less. Okay, you can consider that the mass of electron is approximately equal to 0. Okay, and electrons, they stay outside the nucleus. And next you have protons. Protons, they are positively charged. I mean, if the charge of this is -1, the charge of this will be +1. So they are very heavy, 2000 times the size of an electron. These so electrons are contained in cathode rays. Protons, if you want, you need to devise some technique, or you need to do the experiment which gives you canal rays or anode rays, and these rays contains proton. Okay, and these protons, they stay inside the nucleus. Okay. The next thing is neutrons. They don't have charge, they have mass equal to protons, and they reside inside the nucleus. Okay. So essentially the charge for this we take -1, the charge for this we take, charge for protons we take +1, charge for neutrons we take 0. Similarly, the mass for proton you take, mass for electron you take 0, mass for proton you take 1, mass for neutrons you take 1 as well. Okay. Apart from this, we also know for the fact that how distribution of electrons. So here in Bohr's model we understood that they revolve around certain permitted orbits. So the maximum number of electrons in each orbit is 2n square. Okay. So if this is the first orbit, it can hold a maximum of 2 2 electrons. Okay, it can hold a maximum of 2 electrons. Beyond this, the space is filled. It cannot accept more than 2 electrons. Okay, that is also called as the K shell. Okay, the second orbit is called as the L shell. Okay, that can hold 2 times 2 square, that is 8 electrons. Okay, and M shell, that can hold, M is 3, right? So that can hold 2 times 3 square, that is 18 electrons. Then you have N subshell that can hold 2 times 4 square, that is 32 electrons. Apart from this, there are several other rules that last shell cannot have more than 8 electrons. The maximum that the last shell can have is 8 electrons. Okay, penultimate shell cannot have more than 18 electrons, and the electrons are arranged in a phase-wise manner. That we can see in the next session, how electrons are arranged. Okay, so now in this there are two definitions which we need to understand. One is atomic number. Atomic number is it is the number of protons which is equal to number of electrons in a neutral atom. Okay, the mass number, because atomic number always defines the charge. It can be the number of protons in a neutral atom, or it is always the number of protons in any atom, and the mass number will be number of protons plus number of neutrons. Okay, because only they have masses. Electrons, they don't have mass, so mass number is given by the number of protons plus the number of neutrons. Okay, so this is essentially what we know from experiments. What is the idea of an atom we have till now? We know this. Okay, okay, thank you.